Hi, everyone. I'd like to thank you for joining us today for our webinar, How to Kubernetes, Shipping macOS Logs into Kubernetes. I'm here with John Cabaniss, MacStadium's iOS DevOps Coach, who will be leading the webinar. Just as a reminder, you will be muted for the duration of this webinar. If you have any questions for John, please put them in the chat or questions pane, and we will get to them at the end of the webinar. We will do our best to answer all questions, but if we run out of time, we will get back to you after the webinar. Now, without further ado, I'm going to hand things over to John.
Thanks, Stephanie. I'm John Cabaniss, DevOps Coach here at MacStadium. Today's topic is on making and shipping macOS logs, which, as all of us who do macOS CI/CD or DevOps know, is not always easy. MacStadium, by the way, is the world's largest provider of Mac-based cloud infrastructure. That's anything Apple, Mac Pros, Mac Minis, all that. We've got about 24,000 units worldwide across 5 data centers. So just an overview, monitoring is a core piece of modern DevOps, and you'll hear me talk about builds a lot. Don't necessarily think of builds as the only thing this applies to. 3 basic steps. We got to look at the best practices in the industry, then need to capture a few bits of data, and finally send the data, of course. Modern DevOps really is about everything continuous. You can argue about how many parts DevOps has. People generally agree in 4 basic sections, and some say 5 and some say 6. It's always continuous, and CI/CD is a common term you'll hear associated with DevOps, which has changed a little bit over the years. But the 4 parts you're going to have is culture, acceptance, putting work into monitoring, putting work into capturing, putting work into delivering, automation, infrastructure as code usually, monitoring, and then a way to develop as a group. After you agree on those basic things, you've got to actually get the data. You need basic feedbacks on builds. True agents are really the best. If your company has agreed on an agent that will monitor your system, there's probably a macOS version. So that's the first thing I would say you should do if you really if your culture is advanced in other parts of the company. Agents do cost time and performance. There's a performance hit to monitor your macOS, as well as to monitor anything Linux or anything like that. So after we agree on a few things to capture and a way to how we're going to get it done, you have to send the data. These are commonly called shipping programs. Now, you don't have to worry about this if you have a real agent. If you're using Datadog or Splunk or any of those, that's built into the agent. The ability to ship is not something you have to worry about. If you're not, the 2 most popular best-of-breed programs for open source are Logstash and fluentD. I'm going to say a few times that there's no real winner there. They're both really good programs. I would recommend either one of them if you don't have a way to ship data without in another fashion. We're going to focus on fluentD here for 2 reasons. First off, we're heavy on the Google side. We use Kubernetes to orchestrate virtual machines that are all Apple-based, running macOS. That puts us down the Google path. Pretty much Google supports fluentD, and they've made it Kubernetes and Docker native. Also, there's a group that provides a macOS.dmg. So any bare metal or any virtualization method can grab fluentD, install it quickly and easily, as long as you're running a macOS. So CI/CD, this has changed a little bit. It's morphed over the years. Really, the acronym is more commonly continuous integration, continuous development. For all Linux systems, monitoring is just one of those things that you always do in modern CI/CD. It's not even a discussion point. You will always monitor your system. In MacStadium's customer base, it's hard to say how many groups really monitor every build. My guess is about 5%, and that's after being here for 1.5 years and talking to the majority of our customers. Most monitoring for macOS really comes from stages, and this is one of our benchmark builds, and you see the Jenkins stages that are commonly used. And this doesn't really tell you much. It tells you how long things take, but not why. What happens is, as you hit troubleshooting and you have a problem, it's pretty agonizing. You don't have a lot of good feedbacks here. You can see when something takes a little longer, then you have to do something else to really get any good feedback. macOS groups don't monitor for really two basic reasons. The biggest one is performance hit. In the Linux side of the house, if you have a 10% performance hit for monitoring, that's acceptable, and most try to get less than that, but that would be okay. Given the cost of the Apple hardware itself and the economies the reality is it's about 10 times more expensive to run a macOS build than a Linux-based build. Taking a hit like that on a really expensive build is not something that people want to do. So it's really been a business side decision to go light or no monitoring unless it's really enforced in other parts of the company corporately. Even those who do monitor don't really have a great way to do it. True agents, the two most popular for our customers are Datadog and Splunk, that's why I mentioned them. However, there's a lot of one-offs that use anything under the sun. I've seen a lot of stuff from this groups that do monitor. Open source agents are what we're going to focus on here because you can customize it, you can see the code, you can actually take a look at what the resource is, you can do a lot of comparisons quickly and easily. And given that there's no real set of agreements, that's what we decided to do here at MacStadium to make a template to pass out. So if you're going to talk about culture, you're going to talk about monitoring, and you're going to talk about a performance hit, you have to have an argument as to why. What value do you bring? So we got two examples here that are real world. And this is one of our DuckDuckGo profiles. This is one of the 10 builds we use for benchmarking. Just running some basic monitoring once, you can get a lot of feedback. I ran this on a 12-core machine. We'll talk about these metrics in a minute, but this particular build used just barely over 8.11 cores. And really, that's a good crude estimate. That tells you how to right size. If I've got 24 virtual cores, I can make 3 VMs with 8 cores each if I want to do maximum performance. I can also do, 4 different VMs on 6 cores and just cut off this top here. RAM I don't have to worry about, and we see that's a write-heavy build. And then transmit, receive, well, it's DuckDuckGo, so it's sending out stuff and it's getting some stuff back. All this is pretty standard. And doing this once on a build helps you right size, helps you understand the value of virtualization when you get there. It also helps you understand how many builds you could run on a bare metal concurrently. So you've got a lot of different value options there. This is from a troubleshooting session. When I first landed at MacStadium, getting to this point took about 3 weeks of back and forth with the customer trying to get them to modify their internal tools. The customer said, hey, I got a slow build, and it's a different template. I don't know what's happening here. It might be your hardware. We said, okay. We sent out the scripts I'm going to show in a minute, and these two plots are the only two we need to focus on. They started up the machine, installed the scripts, ran the scripts, and immediately one had 8 gigs, just under, of RAM free. The other one had just under 3. And then the slower one had all this activity on the CPU. Immediately, we said, what's running? This was a dev-based build. It was used for certain things. And the CI/CD team was not as interrelated with the dev team as they thought they were. So then they got immediately some feedback, went back, started asking questions, figuring out why the one template was running a process as soon as it started. And that cut down on the troubleshooting time dramatically. And then you had other feedbacks. Now you can do a PS aux, take a look at everything that's running. You have an idea of what to look at. And if you make the business decision that the slower run, it was necessary, great. You got to do what's necessary for your business and for your builds. If you don't have to, now you know the cost of it. So you can decide intelligently and have a conversation with the dev department or the ops department. What do you want to run? And that feedback, again, extremely quick. That was an afternoon versus 3 weeks of discussing back and forth with dev and getting, network to the right people, talking about what they do, don't do, all that stuff. All the meetings take time. And really, this is part of DevOps. And as I said, continuous integration, continuous development is the original term for CI/CD. That's changed. You hear people say deployment, you hear people say all sorts of things. Whatever acronym you use is fine. It's always a customer first concept. It always comes from the same place too. Customers shouldn't have to wait for bug fixes. And also, hot patches are necessary and need to get out quickly. Once you have a mechanism for delivering those two methods, which is almost always a continuous style, then it's really not hard to make features accessible in the same way. And that's where this comes from. It goes from a emergency bug fix, hey, I gotta make my customers happy, to we can make their lives better, we can show more value with our product by pushing features out as soon as they're ready, not waiting for these larger builds. And there's a whole bunch of extra benefits you get after you get to this point. And people will go on for, keynotes have gone on about the value you get. It's really good for the customers, and that's what the core concept is. And the quick summary, again, you can break this into more than 4 parts. Automation, infrastructure as code, everyone's heard that quite a few times. Group development is really a code repo with ability to track changes, version control, pull requests, all the modern features. There's several of them out there. GitHub's the one we're going to show later on today, but any of them are fine. Monitoring is something you need to do to make sure your builds stay healthy. And the most important part of any of this is the culture, the willingness to work together to get to the common goal. And that's really a bigger factor than people realize. Dev and ops usually are separate departments. The reality is very few companies have a true DevOps department. DevOps, the term, really is about dev and ops working together. Devs can write code with testing in mind. Ops needs to have greater visibility and velocity to devs. Combining efforts is a really good thing. Joint owners is a good thing. Having new ops people train with devs to understand the tests devs do before they go back to ops for their full-time job is a great policy. I've seen that before. That really makes the two departments. First of all, you know each other, and second of all, everyone is friendly. You can express problems to the right people with a higher velocity. Similarly, devs taking a on-call shift, not all the time, but to get to know the problems ops have is a good idea, especially if you can work it out with schedules and so that everyone's happy. A dev who sees what ops goes through when customers have complaint is a more informed dev who has a more customer-focused mindset. It's not their full-time job. That's not what they were hired to do. But ultimately, we all serve the customers, and we make money by making our customers happy. When you don't have this, you have some bad examples. And I'm a former consultant. I've seen a whole lot of companies with some bad culture aspects. If you go away from the team mentality, there's 2 examples I always point to. First was the slowest deployment time. A company just said we can't have multiple dev groups merging to the same code base. It's too messy. And I saw several other like this, but the worst example was a company that really spent 2 months on true feature dev, and then 4 months debugging. That's no fun for anyone. That's not what you hired the devs for. Devs are supposed to be hands on keyboard. And that's 4 months process that happened after every massive code merge. It was really a lot of meetings. It was one group saying, all right, well, we think this other thing broke our feature, so can you fix this other thing? And the group they pointed to said, okay, well, we're partially responsible, but there's these 2 other elements, and it goes on. And the meetings just became really more time consuming than the actual code fixes once the problems were identified. The other bad concept is to throw it over the wall. This is a really, I've seen this a lot of times where devs will make code changes and then won't update tests. Most commonly, and I've seen this twice, changing flags. Documented properly, fine, but no process to update the tests for QA or ops. And in one case, it flooded QA with false failures. In the other case, it flooded ops. It was a consistent thing that this company spent way too much time on. It was probably 5 man days to 2 weeks of man days every feature release that were just wasted effort trying to track down false failures. And that could have been fixed. One single test base, making sure the process, but process comes from culture. You got to have a good process, a good mentality, and then you can have groups working together really seamlessly to serve the customer better. So let's talk about macOS. So macOS monitoring is not as advanced as we would like, but what do you really want? Well, core concepts: RAM, CPU, read-write, and networking. Those are your 4 things you cannot get away from. They're key components to any computer, and they're going to dictate how well you get a job done. And there's some ways to get this fairly cheaply, and there's some expensive things you have to do if you want the right data. So before we take a look at the code, let's talk about the rules. So MacStadium provides infrastructure as a service to a lot of customers. They all have different opinions on what code they want to use, whether it's C, Python, Java, whatever. And in my opinion, there's no real bad answer. There's the answer that your company's decided on. But that leaves us in a little bit of a sticking point where we're trying to serve all customers. So the only thing that I'm going to present today are native macOS commands. If you're using any Apple computer with a macOS, you should be able to run these commands as written, and they should work. Also, I say build a lot, and that's a bad habit of mine. Most of our customers are using MacStadium resources for CI/CD, so that's my mentality. However, we have just as many who are doing unique things. We got quite a few that are doing Safari-based testing. We have others that are doing really sound processing, video processing. There's a whole lot of uses for macOS. macOS does a whole lot of things really, really well. So when I say build, please forgive me, I mean task. It doesn't really matter what you're doing exactly, although a lot of the stuff I'm going to show is more agreeable to an ephemeral, a virtual machine type setup. We can adapt all of this to run on any macOS, no matter whether it's virtualized or bare metal. And ultimately, the 4 elements that I talked about above are part of any healthy build measurements or task measurement system. If you got a job running, you care about the resources. You don't want to be resource constrained. So first thing we're going to talk about is top. This is the best way to get free RAM. Top minus L1. That's it. This is actually what Activity Monitor uses. Pretty much everything Activity Monitor comes from top ultimately. And we're going to do a little bit better job on this, but this is how you would just get RAM in general. So CPU, I like PS. It's going to display all of the different processes and how much of one core they take up. And that's one logical core or virtual core, not one real core. So in almost every Apple machine, we definitely in all the ones we do, but in most of them, you have virtualization hyperthreading. So you get 2 virtual cores or logical cores per 1 physical core. So that means you've got a lot of twice the number of cores you think you do. This is going to display things in terms of 1 logical core. So you're going to see numbers like I showed earlier, where 811% of 1 core, and that is a really quick way to say, hey, you're using a little over 8 cores. This is just going to be a nice, quick way to grab that data, display it. You can then use the same command without summing everything with 1 column to see which cores are actually being used. And you might find out, if you really need to investigate, that even though you're only using a total of 811% of 1 core, so you would think it's 9 cores, you're really using 16 different cores, because your Mac has 24 virtual cores available, and it was running a bunch of really light processes on their own little core. And that may be important to you as a company, and that may not. It's a little bit more work. Read-write, I/O. This is going to be the tough one. So ultimately, a pressure test is best, and that's what TimedDD is. You will need to wrap this into a little bit of code. You can't run this directly. It's a macOS thing, and there's a few other cases where the code's not going to run quite as nicely as you would like. Ultimately, macOS and Linux are both based on Unix. So a lot of the commands for Linux do function on macOS. However, there's an implementation difference. So a lot of the commands that run fine and a lot of the flags that work on Linux don't work on macOS, and you have to be aware of that. Test often, test thoroughly, go one step at a time, follow best basic troubleshooting practices. In this case, I had to do this. If you try and run it from one line, you're going to find that you can't quite get it to the temp file. Then I just do a little awk script, and I've added to this. I also relabeled the title to read write current, and I'm not putting the time, which is $5. This measurement is a pressure measurement. It's in bytes per second natively, but a lot of people don't like that, so I just did a temporal output, which is a crude measurement. The actual amount you write here is going to vary a little bit, and that's just because of how the bit writes and bit reads work. So doing the actual amount written and read divided by the actual time is a more accurate measurement of the pressure. This is the most expensive measurement we have in this set. It's also the best one for virtual machines. In a real Mac OS, you have one operating system, and you're authorized with Mac's hypervisor to try and have 2 VMs if you want. But in general, you don't do that. In a virtualized environment with either vSphere or Kubernetes, you can have a lot of VMs. You can have n number, that depends on the actual what the hardware will support. But they have a shared disk. There is a real physical disk attached to all of those VMs. So this measurement is more important than you would think for a virtualized environment. Do you always want to do it? Probably not. Do you need to do it, especially to profile the build? Yeah, you really do. You need to understand what the read-write pressure is going to be from one single build, and that's going to tell you how many builds can read-write without contention. Getting network in and out, Netstat. In general, I'm just going to let this run, and then we can terminate Netstat later. This is not going to be as efficient as you would want to be for a bare metal machine. However, for a virtualized environment where you're spinning up and down machines often, this is fine. $3 is going to be the in, $6 is going to be the out. Awk's got a nice little feature where you just put end, and the last line is the one it acts on, and a really fast and efficient process. The only thing you got to worry about is the netstat.log file growing. It doesn't happen very quickly, so you have a lot of time to deal with it. And then you just want to use a standard log rotator if you're on bare metal, or if you're running a long-lived application. If you're doing a Safari instance and you're probably going to reboot once every 3 months, then you probably want to cycle your logs and get a good process for that. So let's minimize performance. If we really want to pitch always monitor, we got to get the performance hits down. We really just want to do the most efficient thing possible with the least impact. And to do that, we're going to use top a little bit more efficiently. I've got this one right here where we spout to a file. What I actually do in the code is pipe it into grep, and then we can grab a bunch of metrics. So physical memory, again, free memory, that's standard. You always want to do that no matter what. CPU usage is going to be the total CPU idle usage across all of your cores. So that's in a percent that cannot exceed 100, can't go below 0. That's a pretty good indicator. And in fact, since it's so cheap, you should probably always do that. The disks line from top has the attempted read, read cap, write, and write cap. Useful information. We really care more about the attempted read and write. So if you're, what happened in the last second? How much did you actually read? How much did you actually write? Versus what does your computer think it can do? What does your VM think it can do? Now the capacity is not polled. That's the second field on this little split command here. So you're going to get a static value throughout all your builds. And VMs are a shared resource. So you want to use the split line that gets the attempted read write. You don't want to change netstat, you just leave it running in the background. The only thing we're really dropping, we're using the top command better, we're getting more in line with macOS and how activity monitor works. And then for netstat, we're just monitoring in and out. Getting it going, lots of ways, cron jobs. Think about the minimum viable you want. You can launch it from a Jenkins line or any other CI/CD tool. A real daemon is going to be better. It taking more time, coding it better is always going to be better. It just is. You can do something as simple as this, which is what we do in some of our benchmark scripts where we did DuckDuckGo. We launch it, we do the /kickoff_loop.shell, let it sleep for 10 seconds, get a baseline, run our builds, sleep for 10 seconds afterwards, and then we're going to do psaux and then pipe it into kill -9. That's as simple as that's the lowest level of what you want to do. That's the simplest way to just get it done quick and dirty, especially if you're just doing a one-off or a minimum viable product for your company and trying to just say, all right, here's the impact. So doing this is not that hard. Here we got metrics.shell, which is on the repo that's going to be at the end of the webinar. And again, this is going to be exactly what we discussed. I'm doing a date at the start. I'm now standard end for the Netstat I start. There's the CPU. I'm now grabbing these 3 lines out of straight into grep and then running light metrics into a K8s. There's the pressure test. There's just the awk of the pressure test to put it in the right format. And then I've got K8s as well as a curl command beneath it. You just have to comment out what you want. And then I have a sleep. That's how often you're pulling the system. And it's pretty easy to run. This is in CSV format right now. I'm just going to kick it out to the screen. And we're going to get a decent amount of outputs. Let's stop it real quick. So among other things, we can calculate the number of cores just by looking at the CPU used, that's under 1, and then we have CPU idle over here. So you can do a quick calculation to figure out how many cores you're actually using. Disk read is always useful. We also do the read-write time as well as the actual pressure value here, and a lot of people just want to plot this time. It's a simpler graph. It's logical, you look at it, it just works as you would expect. If you want to do a curl command, you got to be a little bit more clever about it. So this command right here, if you try and do a curl from this simple on a command line, what you have to do is always start like this. These single quote marks mess up macOS. This will not work if you then have a command inside. So all metrics.awk does, and there's a couple of those lying around, is format it for the curl. And that curl is going to kick it out to a fluentD system is how I've got this formatted. And if you use Logstash or anything else, then you format it appropriately. But ultimately, it's still curl. And we can, then there's another metric you want to think about. CPU loop is one of the many examples I've got. CPU loop just does CPU. It's just this sole piece. And the whole point here is you can change it. You can take this one metric that you care about. Let's say you really want to know what your core count is. You're convinced that your 5 seconds is not granular enough, 2 seconds is not granular enough, so we're going to do 0.1. And you make sure that you format everything properly, and PS is a real agreeable measurement to this. Now you're just kicking it out. So now you get a really good measurement of how many cores are you using at any one given time for a build. And that's a really good profiling tool. And you can modify any of the other scripts to do the same thing. So on metrics.awk or metrics.shell, Netstat, this is 2 seconds, and the sleep 2 to get it started, sleep 2 at the end, but also the top -L1. That can be changed. You got to think about what you're going to do, but then ultimately you've got a lot of freedom here to do whatever you want. Get the metrics you care about, get them with the frequency you care about, make it meaningful to your business. Then you got to ship it. So again, fluentD and Logstash, 2 best of breed tools. They're both easy to work with, they're well documented. They do the same basic things. By the way, that's the little original Logstash symbol at the bottom before it was purchased by Elasticsearch. And then they redesigned it to the L. Ultimately, both of them are going to do shipping of logs in a really efficient fashion. They're both going to take anything you want, ship it to wherever you want. That's the goal. Both open source, really healthy plugin communities. I think fluentD is bigger, but they're pretty comparable. There's no real difference there. They're both supported by corporations. Google supports fluentD effectively, and Elasticsearch purchased Logstash, so you have them in the Elastic Stack. They're both written in Ruby with Go forwarders, so really, really similar. If you're going to write your own plugin, you care about one of the two differences, syntax and what they use. You have Logstash with Java-based Ruby, and you have fluentD with C-based Ruby. Most people, if you're going to find a plugin that works for you that someone else maintains and you're happy with it, not a big deal. You can use either one. If you really know you're going to have a dev write something for your application, okay, fine. If you really want to do a true plugin, this is the decision point. Both of them have one use case, which one does better than the other. Logstash aggregates multiple logs better. fluentD ships many logs to many endpoints better. And that's a design choice on the two organizations. Pretty much the workarounds are real comparable. Logstash, you want to have one instance per destination or type of log. And really, it's log type. That means you have more Logstash servers, but that's okay as long as your Logstash is off of your computer you're working on. In the case of fluentD, you would have one fluentD log entry for each aggregate source you want. So you basically have a different transmission for each type or each aggregation. That creates a lot of network traffic. And by a lot, we're doing curls. This may not be that much. It may not stress your network out at all. So that's kind of the difference. And again, if you want to minimize the amount of resources used by your macOS, you're going to have either one of these guys as a server you point to. On macOS, fluentD is easier to install. It's not that bad with the, by the way, Linux Darwin is always, is the macOS version of a Linux application. So if you ever hear Linux Darwin, and you'll see that if you try and look for Logstash, that's the package you want for macOS. And the Apple team makes sure that the Linux Darwin series stays compliant and will install the most recent Apple hardware and Apple OS. But in the case of fluentD, it's even easier. Just install by the DMG. And the group called Treasure Data keeps this up to date. And that's great, like it a lot. The one thing I don't like is the have a TD agent, which reports back. It's this one section of code right here, which installs. It doesn't launch without you telling it to. So TD agent in the config file is tdagent.conf. You can just comment it out, and that's what I do. Now, if you want to support the fluentD team, the TD team that maintains the fluentD DMG, great. If you want to use Treasure Data for their core services and offering, hey, that's awesome. I hope people do, because I appreciate that they maintain this. Until that point, you make that decision. I don't really want to transmit logs. So another useful page for in really output formats. They say input, but it's input to fluentD. So the output outbound from your macOS is the tips and tricks. Not everything works on macOS. So if you're going to, we're MacStadium, so I'm using all macOS systems here for send and receive. But most people won't. You'll generally have a Linux-based VM as your server for either Logstash or fluentD, and that's fine. You need to understand that if you're using macOS to macOS, there's some things that won't work. Piping gzip is an example. This doesn't work when you're sending to a fluentD server living on a macOS. So just test everything. Now, if this was living on a standard Linux VM, it would work just fine and as documented. But that page is going to have some useful information. It's going to give you some ideas on the common transfer methods, as well as encryption, as well as security-based stuff. And it's a great starting point if you want to use this service and it's new to your company. It's a page you can walk over to security and talk to them about what do they want to do. What does fluentD support natively? Then you can get into how you're transferring the data, and discuss protocols that you want to use. Again, this is the curl. You've got to wrap it inside of a different script. You can't launch this directly from the command line. All right, so let's do the last demo. We're going to go to a server I've already made. This is on our Orka system, so let's take a look at this real quick. So here's the VMs I have in existence right now, and so you got 3 VMs up, and we're going to go to this .11. And that's this guy right here. And this is Apple Screen Share. It's a VNC protocol. Installing on a system I've already downloaded TD agent. The subtleties of macOS. macOS works great until it doesn't, and then it's really frustrating. So with the TD agent DMG, double click is normal. That's going to open up this box. Double clicking now is going to get you a frustrating result because it's not signed. And there's no option to open it. Pretty simple. If you don't know the trick, it's very frustrating, but it's a shift right click and then open. And now we can just open it, even though it's from an unsigned developer. And that's what you should do. So we're just going to install this. And we'll need admin password. And we're almost done. That is it. Now it's installed. We can move to trash. And these instructions are actually pretty good. So again, don't jump away from the page. We're not done quite yet. We still have to load. But first, I really don't want to send any data to TD agent. So, and this actually won't work. Whatever you do, it's got to be sudo. Because again, it's pretty locked down. macOS. There we go. Since this is a fresh install, I'm going to do a little demo. Let's look at the debug definition. So we're matching debug anything, so I'm just going to write that log. So I got CP loaded here. So we're going to uncomment the curl command, comment out the, we can actually leave it. It's not going to hurt anything to do both. So we're chmodding the curl command, running the curl command after we act on the actual data with the awk script to get it to format properly for the curl. And we don't need this to be 1 second. We just go 5. So we're not in that much of a hurry here. Now we need to make sure our data is right for the curl command. So right now I got this going out to a guy. Let's change this to make this localhost. Get rid of all networking. And let's go debug. Just to make our lives a little bit easier. So first we got to launch our agent service. And we'll go ahead and unload it. Whenever you do this copy, by the way, macOS issue, you're going to see this little extra $sign. Just be aware of it. And not surprisingly, it's not loaded. Now we load the definition. And we grab this tail right here. And we should just see a worker loaded. That's the normal operation. Yeah, there we go. And now we're just going to run in the background. And we already see an output. So let's go ahead, make this guy a little bit bigger. There you go. We're outputting the same data, both places. That's as easy as it is. That concludes the quick overview of the macOS logging and monitoring. The repo location that we use today is GitHub, MacStadium, macOS monitoring. It's one that we pass out to our clients quite often. It's pretty easy to take a look at. The code's extremely simple, like you just saw. Everything is very user-friendly. And we don't really advocate any particular virtualization system or visualization. We support all of them that run macOS. So thank you for your time. We're ending a little early here. Are there any questions?
Hey, John, we actually do have a couple of questions.
Okay.
So is there a reason you are not pulling metrics with a library or other resource?
I think if that would be a really good idea, especially if you're running like Java, to use a Java library to monitor JVM. Again, we're passing the code out to everyone, and the idea is you can run this on any Mac OS, get a CSV back, plot it however you like. So we don't particularly pick one system. Some of our devs are going to do an Xcode based feedback system, which if you use Xcode is going to be a lot better than this simple stuff.
Fantastic. So our next question is, the time DD command could have had more flags to improve performance. Have you considered this or changed the amount that gets written?
Yeah, so if you're a Linux dev, O flag equals disable, I think, is the standard one that improves performance greatly. That actually doesn't work on Mac OS. There's quite a few flags I have not played with that could help you out, and I would encourage you to go in, do a thorough look at all the flags that you would want to use for a standard Linux build, and pick the set that works on Mac OS that works best for you. Separately, the amount you write, I have played with, and we've had a couple customers play with. We picked 0.5 meg for this, and then my slides, I've got 1 meg of data written and read. A meg is going to give you more consistency and take about 3 times the time to write and read. So we went with 0.5 meg. It was less of a performance hit. I think right now we're at a 1 or 2% performance hit for the full version of the scripts with time DD. Performance hit of writing a meg. But the value of a meg is if you want consistent data, you're going to get more consistent data on the read writes with writing a meg.
Awesome. So our third question is, you haven't touched on visualization much. Is there a program you prefer?
No, not really. CSVs is what a lot of people want to email to us. And Excel is good for that. So is OpenOffice Libre. If you're doing Logstash, they usually pair with Kibana. If you're using fluentD, it usually pairs with Grafana, but there's no strong preference. However you want to visualize is great.
Great. And I think this is our last question. You mentioned various metrics and that monitoring should always be done. What is the most important data to gather, ignoring the performance cost?
It depends on your problem. So we had a customer that was seeing long pull times from a get resource, which it then had to write. So the two that they cared about most were the network traffic to make sure that was healthy, as well as the read write. Other customers have had resource contention on their CPU, so it was far more important for them to do a really microcosm scale monitoring, a really rapid PS command to track how many cores they were using and how good the parallelization was. That's why, and that group also did a core breakdown. Wherever your pain point is, that's the most important for you to monitor. That's where you should put your time and effort on dev side.
Awesome. I actually have one more question that just came through. Do you recommend running the metrics from within a CI build or independent from the CI system?
If you're doing virtualization, I would recommend inside the CI system to kick it off. If you're going to use a script like this, if you're using a real system, if you're actually doing a long-lived static configuration, you need to run it outside the CI system and just have it monitor the whole time. And then you also want to do log rotation. So it really depends on your configuration setup. And again, there's 2 great methods to virtualize, vSphere and Kubernetes on Apple with the MacStadium offering. But I'd say the majority of our customers probably run in the static configuration. And that's just because of the expense of virtualization plus the time. And again, like we discussed, Mac OS is a good, I'd say probably 10 years behind Linux in terms of best practices, adoption, and shift to virtualization and things like that.
Fantastic. I think that those are all the questions that we have, John. I wanted to thank everybody for joining us today. If you would like to watch the webinar, again, we will be uploading this webinar to our YouTube page, so be sure to subscribe to keep up to date. Thanks everyone for joining us.
Thanks everyone.